In this video, we want to consider how to use a distributive property for arithmetic expressions so that we'll be able to apply them to algebraic expressions in the following videos. So let's first consider the problem 5 times 7, which, since we're starting to do algebra, might be better to write as 5 times 7. And we know that that simplifies to 35. But another way we could have done the same problem is to consider 5 times the quantity 4 plus 3. We know that the answer needs to be the same since the quantity in parentheses is equivalent to 7, but we want to use a distributive property to get to it. Now, a quick aside, why are we doing this? Writing 4 plus 3 instead of 7 clearly doesn't make our life easier, but when we move on algebraically, that might be an x plus 3. And we cannot add x and 3 together like we can 4 and 3. So we want to use this video to understand why, how the distributive property works for cases where we might not necessarily use it. So what the distributive property says is that the first factor must be multiplied times every term in the second factor. In other words, we need to fully multiply it times the second factor. So when we go to do that, when we multiply the 5 times the 4, we get a 20. And when we multiply the 5 times the 3, we get a 15. And it's clear that the sum is still 35. Now let's try to visualize why that would work and why we could have two products that would sum to the same thing as one product did. So let's make a little rectangle that is 1, 2, 3, 4, 5 units tall and 1, 2, 3, 4, 5, 6, 7 units wide. Okay, so the original problem would be like taking, it's 7 units wide. If we stack those 5 tall, we're really adding 7 5 times or 5 7 times. But if we look at how the second version of the problem works, instead of 7, we would be subdividing the rectangle so that it was here divided, and that we would have the top part, or I'm sorry, the left-hand part would be 4 units wide and the right-hand part would be 3 units wide. And the area of the left-hand part would clearly be 20, and the area of the right-hand part would clearly be 15, and when we put those two pieces together, we would get 35. It's almost like we used 2 smaller rugs to cover 1 floor. So that would give us the same answer as we had before by distributing the factor of 5 to both terms of the second factor. In other words, multiplying it by the 4 and the 3. Now let's consider another variation on the same problem. Let's switch to red now. Let's take, instead of using 5 plus 7, let's take 4 plus 1, the quantity 4 plus 1, times the quantity 4 plus 3. So we're still working with the problem 5 times 7. So we know the answer has to be 35. But what we need to do is use the distributive property. And when we have 2 terms in the first factor, what we need to do is multiply every term in the first factor by every term in the second factor. Since we have two terms in the first factor and 2 in the second, when we take 2 times 2, we should end up with 4 products when we do this. So the first thing we would do, we would multiply the 4 times the 4, and we will end up with 16. And then we will multiply the 4 times the 3, and we will end up with the 12. Now we should multiply the 1, just the second term of the first factor, times the 4, and that would end up giving us a result of 4. And then the 1 times the 3 would have a product of 3. And when we add all of those things together, sure enough, we get a sum of 35. Now let's divide up our rectangles to see why that would work. So let's first of all erase the areas that we had. And let's redivide. Now the 5 has been divided down. So the 4 and the 3 are still divided the same way, since the 7 is still being divided up into 4 plus 3. But the 5 is now being divided up into 4 plus 1. So this side is now, we'll put it over here on the right, 4 units tall and 1 unit tall. So now we have all of these regions to consider. So the first region, we'll do the lower left, that's the 4 by 4 region. That gives us 16, which corresponds to the first product that we got. The second region would be the 4 by 3 region, which gives us 12, which corresponds to the second term in our result from before. And then we multiply the 1 times the 4, and we'll clearly get a 4, which corresponds to the third term, and a 1 times 3 is 3, which corresponds to our fourth term. And when you add all of those sub areas up, you get a total of 35, just like before. So we can see that the procedure of multiplying every term in the first factor times every term in the second factor made this work. Other things we could do that would be more complicated. We could look at 4 plus 1 times 4 plus 4 minus 1. You'll notice it's still 5 times 7. In this case, we would have to multiply both terms in the first factor times 3 terms in the second factor. So when we do a 2 by 3 kind of multiplication here, we're going to have 6 products that we have to add together. So if we start with the first term, we would have, let me get the right color here, 4 times 4 is 16, and then 4 times 4 again is 16. But now we're going to take 4 times negative 1, so we have to take back 4 units. And then we have to take, we have now multiplied the 4 in the first factor times every term in the second factor. So now we have to go back with the 1 and take the 1 times the 4 and the 1 times another 4. And then 1 times negative 1, so we have to subtract 1. And if you add all of those up, you will again get 35. Now it's a little harder to represent this because we have a couple of negative areas, be like having a carpet that's too big for the room and cutting part of it away to get it to fit the room. Now, none of this was practical at all. It's much easier to talk about 5 times 7. But there are some cases when we're doing mental math where the distributive property is actually very useful. If I had a problem like 57 times 99, it would be pretty hard to do that problem in my head. I can't carry too many digits in my head. But if I were to change the problem to be 57 times the quantity 100 minus 1, it's the same problem. And that one I can do in my head because I know that 57 times 100 is 5,700. And then I have to subtract 57 from it. And 100 minus 57 would be 43. So I know that I have 5,643 left when I do that. And I'm able to do that in my head much more easily than trying to do 57 times 99.